In this video, we're going to look at concentration in consumer products because often molar concentrations just won't work for the average person. Here are our three different types of solutions that we can have. We can have liquid-liquid or volume-volume, solid-liquid, weight-volume, or solid-solid, weight-weight. Sometimes you also see those as M's instead of W's, which would stand for mass. And you can see the formulas. Just remember that we always need to have grams and milliliters when doing these calculations. So in our first example, we have glucose being used to prepare feeding IVs. What is the concentration if 125 grams of glucose is dissolved in 2.5 liters of water? So our solute is our glucose, and our solvent is our water. We do need that 2.5 liters to be in milliliters, so we need to multiply by 1,000. So we're going to be using 2,500 milliliters and 125 grams. So our concentration will be 125 grams divided by 2,500 milliliters times 100. And when you do that, you get a 5% solution, and because it's a mass divided in volume of solution, we say that it's weight volume. In our second example, we have isopropanol, which is rubbing alcohol, in a 450 milliliter bottle with a concentration of 70% volume. Assuming that the isopropanol has the same density as water, calculate the volume of isopropanol in the bottle. So when you're given concentration data in a percent, remember the last thing you do in this formula is multiply by 100. So when we want to put concentration data in, we want to start by dividing by 100. So we're going to be using 0.7, and then our volume of our solution or solvent is going to be 450 milliliters. So we will set up 0.700 equals, and we want our volume of our isopropanol that's found in 450 milliliters. Sorry, I forgot the L over there. So to do that, we're going to multiply our 0.7 and our 450. So we get 315 milliliters of isopropanol in 450 milliliters of solution. Another common consumer product that you will see concentration is parts per million. And to do parts per million, there are several options. We're going to stick to milligrams and liters, and parts per billion will be milligrams per 1,000 liter. We're really just going to focus on parts per million today. So in this example, we have a 3-liter sample of pool water containing 0.65 grams of chlorine. What is the concentration in parts per million? So for parts per million, we always want to have milligrams per liter. So our volume we already have in liters, and our mass is given to us in 0.65 grams. There are 1,000 milligrams in a gram, so that is equal to 650 milligrams. So parts per million is always your milligrams divided by your volume in liters. And so we get 217. We don't put milligrams per liter, we put parts per million. So that is our answer, 217 parts per million. In this example, we're being told that the maximum allowable concentration of mercury in Ontario water is 0.001 parts per million. And it's asking us for what is the maximum mass of mercury that could be found in a 25-liter container of water. So our parts per million, 0.001. We're being asked to figure out our mass, and we have 25 liters. So we would be multiplying these together, and when we do that, we get 0.025 milligrams. So the maximum mass of mercury that could be found in the water is 0.025 milligrams, which is a really, really small number. So that concludes reviewing how to determine the concentration for consumer products.